Welcome to Hartman Math. This is lesson 4.4, solving radical equations. Our steps are going to be to isolate the variable or the radical initially, use inverse operations to undo and solve. To do that, we need to remember that the inverse of a square is square root. Inverse of a cube is cube root. The inverse of a square root is square or squaring. Inverse of a cube root is to cube. In these, it's very important to check your answers. You might have an extraneous solution. That means a solution that we need to throw away. We didn't do anything wrong, it just doesn't fit the original equation. Example number 1. We're going to solve, we're going to check for extraneous solutions. So we want to isolate the root first. So we want to get rid of the plus 5. First step, we're going to subtract 5 on both sides. Square root of x is equal to 10 minus 5 is 5. So we've isolated the square root. Now we want to use the inverse, which is to square or squaring. So we are going to square both sides. When I square the left, I get x. And then I'm going to square the right as well. And what is 5 squared? X is 25. I'm not sure I should have boxed that yet. We do need to check, so let's check. It goes right there. Square root of 25 is 5. Add 5 equals 10. It checks out. Example number 2. This one's a little bit different. I cannot subtract the 6 because it's buried inside of the root. So I have to undo the root first. So I have to use the inverse. The inverse to a square root is to square both sides. So if I square the left, I just get the radicand, which is the part that's underneath. I need to square the right. X plus 6 is equal to 49. Subtract 6, x is equal to 43. Let's check that before. So 43 plus 6 is 49. Square root of 49 is 7. It checks out. It is now your turn. Pause the video here as you work through that problem. All right, well, if we remember from previous lesson, we can rewrite this as a radical. So it's x minus 3 is equal to the square root of 4. I don't have to put the index there. If I don't put it, it's mean square root or second root. What is the square root of 4? That is 2. X minus 3 is equal to 2. And if I add 3 to both sides, x equals 5. Let's check that answer. 5 minus 3 is 2. 4 to the 1/2 power does not mean half of 4. To the 1/2 power means square root of 4. And that is 2. 2 equals 2, and it checks. Example number 3. This one's got a couple different square roots in the problem. It's got some other complexities, so we'll definitely be careful as we work through this. We want to isolate one of the radicals, probably this one. Get this one all by itself on one side of the equation. So to undo this, get this moved over, we're going to undo the subtraction. We're going to add 2 square root x. And if I add it to 0, I'm just going to get 2 square root of x. So we would get square root 12 minus 2x is equal to 2 square root of x. Now, to undo the root, we could square both sides. If I square a square root there, inverses, we just get what's underneath. I'm going to be a little bit more careful over here because it's a product, two things being multiplied. So remember from our exponent properties, if I'm raising this to a power of 2, that's squaring, it has to happen to both of these. So it's 2 squared times, if we square the square root of x, we're just going to get x. So we ultimately get 4x there. So now it's linear. I don't want to get it equal to 0. Probably be a good idea to just add a 2x to both sides. Remember that this is 4x plus 2x makes 6x. If I divide both sides by 6, I'm going to get 2 equals x, or x equals 2 if you want to write it that way. Let's make sure we check this. 2 times 2 is 4. 12 minus 4 is the square root of 8. So we get the square root of 8. And if we remember that to simplify that, that just means root 4 root 2, or 2 root 2, minus 2 root 2. So 2 root 2 minus 2 root 2 is 0. That should check. Anytime we subtract identical numbers, we're going to get 0. So that one works. Example number 4. Over on the right, our square root is already isolated. There's nothing outside, there's nothing in front, there's nothing after. So we should be ready to, because there's only the one square root, undo this root. We're going to square both sides. I'm going to start over here. And then over here, I've got to do x plus 2 squared, which means it applies to all of that, which means we're going to need the parentheses. And then we have to understand that x plus 2 squared means x plus 2 times x plus 2. And then maybe some more side work. We do this x plus 2 times x plus 2. Distribute the x. And we get x squared plus 2x. Distribute the 2 plus 2x plus 4. We combine our like terms. We're going to get x squared plus 4x plus 4 is equal to 2x plus 28. That is now a quadratic equation. That takes us back to Unit 2, solving quadratic equations. One of our strategies, either factoring or the quadratic formula, we wanted to get one side equal to 0. So let's do that. Let's subtract a 2x on both sides. And subtract a 28 so that the right side will be 0. And I think we'll try to factor this. If it doesn't, then maybe we can do the quadratic formula, but do the even. I think I might prefer completing the square. But let's try to factor this. Numbers that would multiply and give us negative 24, something like positive 6 and negative 4, and then if we check outside, inside, we're going to get negative 4x plus 6x is a plus 2x, so it does work. And then remember, we would split them apart. X plus 6 equals 0, x minus 4 equals 0, x might equal negative 6, x could equal positive 4. So let's check those in the original. We've got negative 6 plus 2, that would be negative 4. And then here, 2 times negative 6 is negative 12, plus 28 is 16. Square root of 16 is 4. Negative 4 equals 4. That's not true. That's an extraneous solution, so we're going to have to throw that one out. What about x equals 4? Well, 4 plus 2 is 6. 2 times 4 is 8, plus 28 is 36. Square root 36 is 6. 6 equals 6. That one is true. So the reason that we have to check, the reason that we might have extraneous solutions, is in this step where we squared both sides, we might take a false equation and turn it true. Like we just saw. If it was negative 5 equals 5, not true. But if I square both sides, I get 25 equals 25. That's now true. So that's why we have to check. And this one is x equals 4. It is now your turn, so go ahead and pause here while you work through that problem. So the square root is isolated. We would square both sides. I'm not going to show the side work on this one, but when you do square x minus 1, meaning x minus 1 times another x minus 1, you should get x squared minus 2x plus 1. And then if we get everything on one side, 0 will equal x squared minus 3x. And minus 1 to both sides means the ones are going to cancel. We're right there. We're going to then factor that. The greatest common factor. Factor out the x. Either x equals 0 or x minus 3 equals 0. Let's check the 0. 0 plus 1 is 1. Square root of 1 is 1. 0 minus 1 is negative 1. Does 1 equal negative 1? It does not. Let's try the 3. 3 plus 1 is 4. Square root of 4 is 2. 3 minus 1 also 2. 2 equals 2. One is right. It is possible that they could both be extraneous, so we throw them both out, in which case the answer would be no solution. In example number 5, we now see some cube roots. Remember back to the original that the inverse of cube roots is cube or cubing. So we'll keep that in mind. The radical is already isolated, so we're going to raise both sides to the third power, that is cubing. So well, this one works out pretty good since it's just cube root equals cube root. If I raise this to the third power, the roots cancel. I would just get x minus 6, the radicand. Same thing over here, I would get 3x plus 24. If I subtract an x on both sides, I get 2x. So if I'm dedicated to getting my x's on the right, should probably get the numbers on the other side, so we'll subtract 24 on both sides, in which case x would equal negative 15. Let's check that out. Negative 15 minus 6 is negative 21. Now if this was a square root problem, that would be an issue because in the real number system we're not allowed to square root a negative number, but with odd roots we can odd root positives or negatives. So that's for cube root as well. So not a problem. We would get the cube root of 21. And over here, 3 times negative 15 is negative 45 plus 24, negative 21. Cube root negative 21 on both sides. We are okay. Example number 6, slightly different. The plus 6 outside of the root, so we want to isolate. We want to remove the plus 6. We're going to subtract 6 on both sides. 12 minus 6 is 6. Now we want to undo the cube root. By the inverse, we're going to cube both sides. So if I cube the left, I got to cube the right. And then 6 to the third power, whether we know that or input that on a calculator, we're going to get 216. Let's check that. The cube root of 216 is 6. Plus 6 is 12. It checks. Example number 7. Now we have some rational exponents. So there's a couple ways that we can do this. I'll show both. But first, we would want to isolate. So the 2 is, the 1/4 power only applies to the x. It doesn't apply to the 2, so we can get rid of the 2 right away. Undo the 2. Since this is multiplication going on, we'll just divide both sides by 2. So x to the 1/4 power is going to be 4. And then the 2 possible ways that we can go would be this. We could rewrite this from exponent notation into radical notation, make it a root. It's the 4th root based on the denominator, and it's to the 1st power. I don't need to write that 1st power there. And then from there, undo the root, we could raise to the appropriate power. So that would be the 4th power. So raise to the 4th power, raise to the 4th power. I believe that that would mean x is 256. So 256, take the 4th root, is 4 times 2 makes 8, and it works. The other way that you could go on this one is to raise both sides to the reciprocal power. If I raise this to the reciprocal power of 4 over 1, which is just 4, and do the same over here, raising a power to a power we've previously learned means multiply the exponents. And if they're reciprocals, the answer is 1. So this is x to the 1st power. And I don't need to write x to the 1st power. It's just the same thing as x is equal to 256. So either way you want to go is fine. Use a similar approach here on example number 8. If we wanted to, we could rewrite this as a cube root. The index, the denominator is 3, so the index is 3. Cube root of 2x plus 5. To undo subtraction, we're going to add 1 to both sides. To undo cube root, the inverse would be cubing. So 2x plus 5. I'm going to raise to the 3rd power. We're just going to get 2x plus 5 raised to the 3rd power over here. 2x plus 5 is equal to 125. By calculator or remembering, we subtract 5 on both sides, we get 120. X is 60. So once again, 2 times 60, 120, plus 5 is 125. Raising to the 1/3 power means cube root. So the cube root of 125 is 5. 5 minus 1 is 4. Or we could have raised to the reciprocal power, so 2x plus 5. And then if I raise to the 3rd power, that's the reciprocal, that goes away. I've already got to here, so I added 5, so that would be equals 5 to the 3rd power. You can kind of see we're right there. So we can either rewrite and then undo, or just raise both sides to the reciprocal power. So one thing that solving radical equations is going to allow us to do is, as we move towards square root and cube root functions, maybe graphing them and analyzing key characteristics like intercepts, it's going to allow us to find the x-intercepts. So that's our task here in examples 9 and 10. Find the x-intercepts and y-intercept for each function. For the cube root, we're going to see later, it's guaranteed to have a y-intercept. Square root functions not necessarily guaranteed to have a y-intercept. Same thing on the x's, but we'll see. All right, so y-intercept is generally going to be the easier one, so we'll go after that one first. And that's the same for all functions. It just means replacing x with 0. So we're finding f of 0. Zero plus 4 is 4. Square root that, you get 2. 2 minus 3 is -1. So 0, comma, -1. X-intercept means set the function value, the whole thing on the left, equal to 0, and then we'll solve. So we want to isolate the radical. We want to undo the -3, so we'll add 3 to both sides. We'll now square both sides. So x plus 4 equals 3 squared. That's 9. So if I subtract 4 on both sides, we're going to get x is 5. So 5, 0. Let's try that here again for a cube root problem. So we would start with the y-intercept. You don't have to, but I like to. G of 0. All right, so we would get the cube root of -1. What's the cube root of -1? It is -1. Times 2 is -2. Add 4 is 2. We've got a y-intercept of 0, 2. All right, let's find the x-intercept, setting the function equal to 0. Subtract 4. We'll undo the addition first. Now let's get rid of the 2. Divide both sides by 2. Now we'll cube both sides. So -2 raised to the 3rd power is -8. If I add 1, I'm going to get -7. So -7, 0. That's it for today. See you next time.